Good morning. Welcome back. Hope you had done well in your tests. Last class we did linked list, that is creation of linked lists. So what is a linked list? It's a collection of nodes where each node has a data or the information part and a link part. The link part would be pointing to the next node in the list. So why is it pointing? Why do you need a link part? Because in an array, when I say it's 100 elements, for example, then you will get that many blocks of bytes of memory together in one block, wherein the array name is a constant pointer which points to the first memory location of the first element, that is a of 0th element, where a is the array. So it will be continuous one next to another. Why does it happen? Because you assign or allocate that memory during compile time. That is, during compile time the memory gets allocated during the before the execution. So you will know how many bytes you need, and that many bytes would be allocated as contiguous memory locations. So you don't need a link part to know which is the previous or the next element. It is very easy to traverse, wherein the array name would point to the first element, that is the memory location. It would hold the memory location of the first element. It's a constant pointer to the which points to the first location of the first element. So it is very easy. Whereas in a linked list, you dynamically allocate memory. That is, you can increase the size or decrease the size. Allocation and deallocation happens during runtime. So every time you need to uh, insert an element, you need to create a node that is dynamically allocate memory for that using new, and then you need to insert. So you're not sure how many you would need. So every time you create, the memory would be allocated wherever it is available. It will not be continuous in nature. So it will be scattered throughout the memory. The nodes would be scattered throughout the memory. They would be logically linked to one another. They will not be physically stored one next to another. So that is why you need a link part which would point to the next node in the list, so that you can traverse the list. Otherwise, you will not know where the next node would be. So that is why we would need a link part. And then the head is a pointer. You can have head, start, first pointer, anything. Like head is not a keyword over here, but then I would be using head. Head as a pointer which would point to the first node in the list. So you will know where your linked list begins is head is pointing to the first node. Otherwise, it would be having null. So head is also a pointer which would point of the type node, structure node, because it would be pointing to that type, that is, it is pointing to a node. And then the how do you know which is the last node? Because the link part of the last node would be pointing to null. So other nodes in a single linked list will have the information, that is, will have the address of the next node in the list. That is, the second node will have the address, or the will be pointing to the third node in the list. So you can traverse in only one direction, because you will not have the information about the previous node. That is, the traversal happens from the first node to the last node, and then you from last again to first is not possible in a single linked list, but single circular linked list you can do that. So in a single linked list, the last node link part would be pointing to null, and the head would be pointing to the first node in the list, and each node will have the information or the data, the information or the location, or would be pointing to the next node in the list. So this is how they are logically connected to one another. So when I create a linked list, I need to first create a node, dynamically allocate memory, store the information part, make the link part point to null, and later I will say whether it is the first node or not. If it is the first node, how will I know? Because head is null. So I will say head is equal to the new node. Since both are pointers, you can directly allocate it. Pointers, pointer 1 and pointer 2. I can say PTR star PTR 1, star ptr2. If you have 2 pointers, then ptr1 is equal to ptr2. I can directly allocate. If it's a variable, I need to say ampersand of x, because you need to allocate it to the memory location. Since both are pointers, it would be pointing to memory location. So that is why directly I can assign like x is equal to y, where x and y are pointers of the same type. And then here also what I will do is head is equal to new node, so it becomes the first node. Otherwise, you need to traverse the list until you reach the last node, and then make the last node, instead of pointing to null, point to the new node. Anyway, I have made the link part of the new node point to null, so automatically it becomes the last node in the list. So this is how I create a linked list. We'll go through this program while going through the code also. I'll explain you what exactly it does. So class is a keyword with the help of which I can create a class. Linked list is the name of the class. Linked list is not a keyword, it's a concept, or it's a data structure. I have named my class as linked list, and then in the private section of the class, private is an access specifier which states that the data members and member functions declared in private section cannot be accessed by anything outside the class. Only the class member functions and the friend functions can access the private data of the class. It does not get inherited. Also, private data never gets inherited. So I have to create a structure of the node first, like what would be my information part and what that would be the link part. So instruct is a keyword, so with the help of which I would create a structure. Node is the name of the structure, and then structure would be written into curly braces and terminated by a semicolon. Don't forget to terminate it by a semicolon. Int info. Info is a variable which is going to store integer data, and that is the information part of the node. A singly linked node will have two parts. One is the information part, the other one is the link part. So in the information part, I am going to store integer data in a variable called info. So I have declared that here, and then I have, how do I create a pointer? Like suppose if it's an integer pointer, I will say int star ptr, where ptr is a pointer which is going to point to a location which holds an integer value. That is what I'm going to say. Same way, if I say star link, link is a pointer which would point to what is the data type, a structure node. So that is what it means. And since it would point to something of the same structure, because link here, this node, link is a part of the node, again it is going to point to a node itself. That is why it is called a self-addressing pointer. So referential or self-referencing, self-addressing pointer. So I'm closing my structure over here. After that, I'm creating two more pointers of type node. Like that would also be, these two pointers will also point to a location which holds the structure node. That is star head and star current pointer. That is why data type is node, and then star head, star current pointer. So these two are again a pointers which points to a node. Then in the public section, these are the data members of the class which is declared in the private section. I don't have any member functions declared in the private section. I have in the public member functions declared. The first one is a linked list. It's a constructor to which I am not going to return pass any argument. So it is a default constructor and does not return any value. Same name as the class name, returned in the public section of the class. After that, void create int. So create is a function which is not going to return any value, but I am going to pass an integer argument to it from the calling function during the function call. So during the function call, the parameters which you pass is called actual parameters. The one in the function header, that is the call function header, is called the formal parameters. So I'm going to pass one argument during the function call of the type integer. This is called function declaration. I have just declared it, that what is it going to return and what are the arguments, if any, and how many, and what would be the data type of it, and the name of the function is create. So I would be defining it outside the class, declaring inside, defining it outside. Always make it a practice. Like when you say declare and defining it inside is easy. I don't say it is not difficult, but then in the long run, see, whatever you declare and define inside the class would become an inline function by default, and so you would get a lot of warnings when you execute it. So many a times some examiners, external examiners, are very particular about it, and you may lose marks even in your final exam if you are getting out of out and you have written this kind wherein you declare inside and define it inside, you may lose marks. So always make it a practice. It is not difficult to declare it inside and define it outside. So void create int, that is integer argument it is going to take, and then create is a function and it is not going to return any value. The same way display is not going to take any arguments, it is not going to return any value, and then the name of the function is display. These two are the member functions of the class linked list. After that, I have closed the class and terminated it with a semicolon. This is the class linked list, and now I will start writing linked list. What I have to do to begin with, head is null. Why is head null? Because write null when you are assigning null is a value, make it in capital. Write it in caps, like NULL in caps. It's a value. I can compare it also. So head is equal to null. So in the program when we wrote, I wrote head also in caps. So you can write it in caps here. That is, it's nothing but a variable, right? Pointer variable. So you can name it the way you name it. Please use it, because C++ is case sensitive. Since it's not a keyword, uppercase or lowercase, the way you declare, you have to use it everywhere the same in the program. It doesn't make any difference. If it's a keyword, then only it has to be written in the lower case, because keywords are written in lower case. Since head is not a keyword in the program, if I had written it like when we wrote the program on Saturday, on Friday we did it in uppercase. So if you write it that way also, everywhere it has to be uppercase throughout the program. Here I am using lowercase, so I will continue using the same. It does not make a difference. But if there is a mismatch in the case of declaration and then usage, it will give you variable not defined error. After that, linked list, head is equal to null, because when there is an empty list, when there are no elements in your list, head would be null, because there are head would be pointing to the first node in the list. Since I haven't yet created my linked list, there are no nodes in the list, so head is equal to null. After that, I am writing for the create function. So how do I write it, or how do I define it outside? The written type of the function, name of the class to which it belongs to, scope resolution operator, name of the function, and then the argument list. This is called the function definition. In the function definition, it has two parts, the function header and the function body. So this is the function header, and this num, that is called the formal parameter. The parameter in the function header is called the formal parameter. And then I have, what does this line do? This line creates a pointer called new node of the type node. That is, it would be pointing, new node would be pointing to node. That is, then what is this new? New is a keyword. See here, new is in white. Keywords always gets reflected in white. New is a keyword. What am I doing here? New is equal to new of node. I am dynamically allocating memory. So when I say node, how many bytes of memory would be allocated to that? When I pass node as an argument to new, that many bytes of memory to store one information of one node would be allocated, and that would be new node would be pointing to that location. Since new node is a pointer, it will hold the memory location of that block of memory. After that, since new node is a pointer, I cannot use dot operator here. I need to use arrow. So new node information is equal to num, the one which I passed during the function call. That value gets stored into the info variable of the structure. So you are storing information part, which is an integer. So num is also an integer, info is also an integer. Where do I declare info? I have declared info in the structure, right? When I created the structure node, I have declared it there, and that information, whatever I pass from the calling function, is stored in info, and I am making link part of the new node to null, right? So first, that is what we did. Take in the information part, store it, and then you make the link part to point to null. After that, I need to check whether that node, whatever I created now, is the first node in the list, or there are many nodes in the list, many or more than one node. Actually, are there any nodes in the list, or this is the first node in the list? If head is equal to null, yes, if head is pointing to null, it means that there are no nodes in the list, because head always points to the first node in the list. So if head is equal to null, I make head is equal to new node, right? Head is equal to new node, because that would be the first node which I have created. That is, head would point to head would point to new node. Since both head and new node are pointers, you know, don't need an ampersand over there. Directly you can assign the value of one pointer to another. So head is equal to new node. Since head would be pointing to new node, it means that the new node which you created is the first node in the list. Anyway, I have made the link part point to null, because when there is only one node, it would be the first node as well as the last node. So the link part would be null, and head is pointing to that. Otherwise, like suppose I have more than one node, next time when I create, what happens? It means that head will not be null, because it would be pointing to the first node. So I need to traverse the list until I reach the last node, and I need to make the link part of the last node. Instead of pointing to null, I need to make it point to the new node which I have created, because that is how you create a list, right? So I need to make the link part of the last node instead of null to point to the new node, and anyway I have made the new node's link part point to null, so it gets attached. So what I'm going to do, I'm going to make a current pointer. Current pointer also I had declared in the I had declared, right? That is node star head comma star current pointer. So current pointer is equal to current until the current pointer's link is not null. Starting from head until the current pointer's link is not null. Current pointer's link will be null only when it goes to the last node in the list, because the link part of the last node is null. Otherwise, every node would point to the next node in the list. So what I am doing here, I am starting from the first node. How will I do that? By making current pointer point to head, because head always points to the first node in the list. The same way the current pointer points to head, and then I will traverse the list using current pointer until I reach the last node in the list. How do I know it is the last node? Because the link of the current pointer would point to null once I reach the last node. So what am I doing? Until the link of the current pointer is not null, current pointer is equal to link of the current pointer. So current pointer is equal to current pointer link. The link part of each node would point to the next node in the list. So when I say current pointer is equal to current pointer link, it would go to the next node. The same way it goes on, and once it reaches the last node, the link part becomes null, and so it goes out of the while. Here when it comes out of the while loop, current pointer would be pointing to the last node in the list, because only the last node's link path would be null. So that time this condition becomes false. It goes out of the while, and that time when the while loop, when the control exits the while loop, the current pointer would be pointing to the last node in the list. And what am I doing here? I am making the current pointer's link would be pointing to null, otherwise it will not come out here. So instead of null, I am making the current pointer's link point to the new node. So automatically the new node gets attached to the list. I am making the link of current pointer is equal to new node. New node's link automatically is null, because when I created only, I have taken in the information part and I have made the link part point to null. After that, display operation. Display is nothing but starting from the first. This is a traversal. I can say you're visiting each node exactly and you're printing. What is the operation I'm doing? I'm just printing the data which is present in the information part of the node. So I'm starting from the head. I'm going to traverse until the link becomes null. So see out current pointer info. Why is it info? Because that is the variable in which I am going to store the data. And then I need to go to the next node. Then how will I do that? Because each node's link path would point to the next node in the list. That is why current pointer also, I'm starting from head and I'm going to traverse. So current pointer is equal to the link of the current pointer. Current pointer info I'm going to print, because I'm not printing the link. Here I'm going to do that, and once it goes out, I'm going to print the information of the last node. That, and then I have main. First, to access the data, that is, memory gets allocated to a class only when you create an object of the class. And when I create an object, also the constructor would be executed automatically or invoked automatically. You don't explicitly call it. That is, unless it is a parameterized constructor. Default constructor gets executed every time an object is created to the class. So how do I create an object? Class name space the object name, and then I have an int ele. What is ele? Is a variable. It is going to store an integer data. Why do I need it? Because I need to take in that information and need to pass it to the function during the function call. There in the function header, I had num. Here I have ele. That is what ele is, an actual parameter. Num is the formal parameter. That is the name of the actual and formal parameters. See, I can say here, where is the function call? See, here is the function call. I'm passing ele over here. This is the actual parameter, wherein the formal parameter is over here. Right? Is over here. The name of the formal and the actual parameters need not be same. Doesn't matter. You can name it anything, but then the data type and the number and the order in which it is there in the function header should match. So I say I have only one integer, then other it is, see, I have an integer, num is also integer, ele is also integer. It is only one I am passing. The name does not matter. The name need not be same. But the data type and the number means number of arguments. Here I am talking. Unless you have default arguments specified, it has to be same. And the order in which it is declared. Like if I have int and float, you have to pass it in that order only. You cannot pass it in float and int order, whereas you have declared it in int and float order. So that is what I'm trying to tell here. That is why I gave a different name also, so that you will know the difference, like int ele and int this thing. I have char ch is equal to y. I have used a logical operator or instead of converting it into a case. Or means either one of that is true. The truth table, if both the inputs are false, then only or will give you false. Otherwise, it will be true if one of them is also true. That is, ch can be equal to lowercase y or uppercase y. Any one of that is true also, this while loop will execute. That is how the logical or works. Then I'm asking the user to enter the information part and taking it in ELE. After that, I'm calling, this is the function call, using the object dot. That is how you access the data or the members of the class, using the object name dot the data member or member function. So create is a member function. I'm going to pass an integer value, that is ELE, whichever the user enters. And then after that, do you want to add one more? I'm asking the user because he would want to create more than one. C in ch, if the user says yes, whether it is in upper or lower, the while loop will execute. It will ask you to enter the information part, take in that and call the function using the object dot the function name, and then the parameter or the ELE is an argument which is passed to the called function. After that, once you say no, it will go out of the while loop, and then I'm printing the contents of the linked list. That is, when I say contents, I would be printing the data which is there in the information part of the list. Get ch. So I want you to go through once. Now we will execute it. File, run. Enter the information part. So let me say I will enter 9 because it's an integer, right? I will say yes, I want to add one more. Again, I will say I want to. It's not compulsory that you have to enter it in any order. I am doing it because I want to do it. It's not compulsory that you have to enter the data in any order. It has to be, it can be any, whatever data you want to enter. Do you want to add one more? I'll say no, I don't want to do it. So you're printing, it is printing you the contents of the list. Yes, the way in which I entered 987 are the contents of the list, that is the information part of the list. It has got created, you can see that, and data got stored, and then I'm able to traverse it using the current pointer, and I'm able to print the data which is there in the information part of the list. Yeah. So we'll exit. Hopefully you have understood the creation part. So we finished the execution. Hope you have understood the creation of a linked list. Now we'll talk about the insertion. So insertion of a node. Already insertion happens when you have already a list existing. So I already have, suppose, a list of 10 nodes already is present. Then you can insert a new node in the beginning of the list. That is, make it as a first node. Totally there will be 11 nodes, but then the whatever node you created now would be the first node. Either you can make it that or the last node in the end, in the beginning, in the end. So make it as the 11th node or anywhere in between. Like I want to insert the new node as a fifth node. That also can be done. So you can add or insert a node in the beginning of the list, at the end of the list, and at a given location when you have already an existing list. So we'll start with insertion of a node at the beginning of the list. First I will write the algorithm and then I will show you, because this is the first node in the list. This is the new node. How will I make it according to the algorithm? How will I make it as the first node? So we will do the beginning, the end at a given location. All the three algorithms we will do, and later I will show you a program how it works. That program creation is there for your lab, but then I will show you how exactly the beginning, the end as well as the given location works. I will execute it and show it to you. So first we will start with insertion of a node in the beginning of the list. The algorithm for insertion of a node at the beginning of the list. Write down the statement: let list be a list stored in memory, comma, head gives the address of the first node, first node. This algorithm inserts item into the list as the first node. Inserts a node into the as the first node. Inserts, I can say item also, item into the list as the first node. So already existing it is there, but then I will create a new node and make it as the first node in the list. So this is the statement of my algorithm. So step 1. What would be the step 1? I need to create a node, right? That is the first step every time. Create a node and store its address in the pointer. New node. That is what I did every time. Every time whenever I created a linked list also, I created the node that way. Here also I will do the same thing. So new node is equal to address of new node. After that, what am I doing? Step 1 is done. That is, first I created a new node and stored its address in the new node pointer. After that, step 2. What will I do? Copy the information of the new node in the information part. Copy the information of the new node in the information part. How will I do that? Info of new node is equal to element. element, item, whatever. After that, the link part is there. Set the contents. Let it be step 3. Set the contents of the link part to contain the address of the first node. Otherwise, when creation used to happen, I used to make it as null. Here, how will I make it? Make it point to head, because head is the one which points to the first node. So, how do I make the new node point to the first node? Make it point to head, which automatically points to the first node, right? So, set the contents of the link part contain the address of the first node. How will I do that? Is equal to head. Because head, this is, I'm talking about an already existing linked list. So head would be pointing to the first node. When I say link of this points to head, means automatically it would point to the node to which head is pointing to, which is nothing but the first node. Getting it? I will show you with the diagram also. Step 4. What after that? Make the new node as the first node of the list. When it will be first node? When head would point to the new node. Make the new node as, this is not new node. Yeah, this is new node only, as the first node of the linked list. How will I do that? Head should always points to the first node of the list, right? Then step 5, exit. So this is the algorithm to make it the first node in the list. I will go through this again. For example, see, I have this linked list wherein head is pointing to the first node. I have stored information 256 there, and link is pointing to null, because there is only one node in my list. Fine. After that, I have created one more node. I have stored the information part there. This pointer is not null. Okay. So first, we'll go through this algorithm, create a new node and store its address in the pointer new node. So address of new node, yes, new node is pointing here. After that, what am I doing? Copy the information part of the new node in the information part. So, I copied the information. I made it 165 over there. After that, set the contents of the link part contain the address of the first node. How will I know which is the first node? Head would be pointing to the first node. So, make the link part of the new node point to head. So, is equal to head means where is head pointing to? It is pointing to the first node. So, when I say new node, link part of new node is equal to head. So, again automatically it would point to the first node. Let us do here. Here the new node's link part shouldn't be pointing to null. It should point to the head. I'm making head, right? New node is equal to head. So, where is head pointing to? Head is pointing to this place. So new node link part should also point to this node, correct? Yes? So it would point here, 1 second. Because it is pointing to head, it should point here, right? That is what I did. That is link part of new node as point is equal to head. What is head pointing to? Head is pointing here. So automatically the link part is pointing here. And then this is null only. It is pointing. It is correct. So then after that, where is head pointing? Head is also pointing here and new node also is pointing here. Both of them are pointing there only. That is why then after that make the new node as the first node, because only thing I did in the step 3 is I made the new node point to the first node in the list. After that I have to make the new node the first node. How will I make it? Head is equal to new node. So head should point to the new node instead of pointing to this. So here it should not point, head should point to new node. Yes, head is pointing. You can see this headings. This is the first node. Head always points to the first node, and then new node is pointing to the second node. This first node becomes the second node, and then the second, if there are no nodes, it would point to null. Otherwise, it would point to the third node, and so on. So you can see this. This is how you insert an element as the first node of the list. Yeah, that algorithm. Hopefully, you have written it down. So you have written down the algorithm, hopefully, because you need to write it down along with me. So please note it down if you have not. Now let me write the code module, only the function to insert. So I will write, and when you create a linked list only, you can add it in that program, or I will show you how to do it. So the code module, only the function which will add the list in the beginning. How will I do that? That is function to insert and make. Write it down along with me. Function to insert a node at the beginning of the linked list. So this is only the code module which will insert a node in the beginning of the linked list. So let me say it's void, that is the function does not return any value, and then let me name it as insert beginning. Okay, INSBEG would be insert a node in the beginning. This is what I'm going to give the name of my function, and then int num. So int num is a argument which I am going to pass when I am calling the function. So first thing, according to the algorithm, what I need to do, create a node and store its address in the pointer new node. So how do I do that? First I need to declare it, right? Before creating, I need to declare it. Then only I can, first I need to declare a pointer new node. Then only I can create and store the address. So I will say node star new node. This is a, that is, I'm declaring a pointer new node which is going to point to a location where node structure is stored of the type structure node. That's correct. After that, how do I allocate memory to it? So I'll say new node is equal to new, how do I say that? New node is equal to new of node. New is used for dynamically allocating memory during runtime, correct? So new node, first I have to create a new node, pointer called new node, which would point to a location node, like which will hold the structure node. That I did that. After that, I have to dynamically allocate memory, make the point new node point to that allocated memory space. New is a keyword which is used for, new is an operator. So yeah, it's a keyword that's different. New is used. New and deleter operators used for allocating and deallocating memory during runtime. So new, I need to pass node, the whatever number of bytes is required to store one element of node, not element, like one node data, that many bytes would be allocated and new node would be pointing to that location. After that, what is that? You need to do second, that I did. This one is done. This one is, now you need to copy the information of the new node in the information part. How will I do that? New node, since it is a pointer, I will say info. I would have declared this info as a variable of the new node is of the structure node is equal to num. So I'm doing this. After that, what will the next thing is? I stored the information part, set the contents of the link part, point contain the address of the first node. So I need to make it point to head because head would be pointing to the first node. So is equal to head. Sorry, this is the okay. So this is done. After that, the next is make the new node the first node in the list. That is what I have to make the new node the first node in the list. How do I make any node first node? If head points to that node, that is the first node in the list, correct? How will I do that? Head is equal to new node. This is the end of my function. This is how I am going to insert the node at the beginning of the list. First, I have to declare a new node, dynamically allocate memory to it. After that, take in the information part and then the link part, make it point to the first node. That is why I am making it point to head, because head would be pointing to the first node in the already existing list. After that, this new node and head are pointing to the first node. So automatically this new node will not become the first node. It is only another pointer which points to the first node. That is the link part of this is pointing to the first node. So then if you want to make the new node as the first node, you need to make head point to the new node, then it becomes the first node, and then there is no break in the chain because new node is pointing to the at present first node, which automatically becomes the second node when head points to the new node. So getting it? Hopefully you understood this. Please make a note. Now homework questions. Please write the solution of 2 and 3 marker questions in the CS question paper, right? I can say solve the 2 and 3 marker questions in Saturday's CS paper. Commerce students can borrow it from the science students, the question paper, and do it. Hopefully you have understood this. We'll do the insertion in the end in the next class, algorithm and this. And again I'll have a look at your syllabus and then I'll just check whether anywhere in between is there or not. If it is there, we'll do that also. Take care, stay safe. See you tomorrow. Bye-bye.